In problem 1, it says determine the number of diagonals that can be drawn in a convex polygon that has 100 sides. Now, if we start with a triangle, we can't draw any diagonals because you can't count sides as diagonals. So with 3 sides, there's none. What if we have a quadrilateral? Well, let's count the sides. So a quadrilateral is going to have 2. What if we have a pentagon? All right, so we got the sides, and then 1, 2, 3, 4, 5. All right, so what's the logic behind all this? Well, if you look at the number of vertices, what you do is you have to subtract 3. Why 3? Well, you can't draw a diagonal to that same point, so that's one of them. And you can't draw a diagonal to 2 of the points that are on the outside, because those count as sides. So, if there are n number of sides, then from each one, we're going to have n minus 3 diagonals, or n minus n vertices. Let's say that. So to get the total number of diagonals, then we take n times n minus 3 all over 2. We divide by 2 because in the example of this diagonal, it's being drawn from this one and from this one. Well, it's not going to count twice. It's only going to count once. So that's why we divide them by 2. So here we're saying if we have 100 sides or 100 vertices. So that means we plug in 100 in for n. So 100 times 100 minus 3 over 2. So take 100 over 2, that's 97 times 50, and so that means we get 4,850 diagonals. There's our answer, and we're done.